Explain the difference between deep copy and shallow copy.
In Python, the concepts of deep copy and shallow copy pertain to how objects are duplicated, particularly when dealing with compound objects, those that contain other objects, such as lists of lists, dictionaries of lists, or custom class instances containing nested attributes. Understanding this distinction is crucial when copying objects in order to avoid unintended side effects that could arise from shared references in memory. A shallow copy creates a new object, but it does not recursively copy the objects that are contained within the original. Instead, it inserts references to those nested objects into the new container. In effect, the outer container is duplicated, but the inner objects are shared between the original and the copy. This means that if any of the inner, nested objects are modified in the shallow copy, the change is reflected in the original object as well, since both objects are pointing to the same memory address for those inner elements. For example, consider a list that contains another list, A equals 1, 2, 3, 4. If you perform a shallow copy using B equals A dot copy or import copy B equals copy dot copy, the outer list B is a new object, but both A0 and B0 refer to the same inner list 1, 2. Thus, a modification like B00 equals 99 would also affect A, changing its first inner element to 99 as well. This behavior can lead to bugs if developers mistakenly assume that all levels of the data structure have been fully copied. In contrast, a deep copy recursively copies not only the container, but also all the nested objects contained within it. This means that the new object is entirely independent of the original, and changes to any part of the deep copy do not affect the original in any way. Using the same example, a deep copy can be created using the copy module, import copy. C is copy.deepcopy A. In this case, C is a completely new list with newly created inner lists. Changes to C0, 0 will not affect A00 because they are now distinct objects residing in different memory locations. Deep copying is particularly useful when dealing with complex data structures where complete independence from the original is necessary. However, it comes with a performance cost as it requires traversing and copying every element in the object hierarchy. In addition, deep copying can be problematic with objects that contain references to external resources like file handles, sockets, or other non-copyable elements. Developers must also be cautious with objects that reference themselves, circular references, although Python's deep copy handles such cases gracefully using a memoization dictionary to avoid infinite recursion. In practice, choosing between a shallow copy and a deep copy depends on the specific use case. If you only need a new outer container and the inner objects are either immutable or intentionally shared, a shallow copy is sufficient. However, if you need a truly independent clone of the entire structure, a deep copy is necessary to prevent unintentional data sharing and ensure data integrity. Awareness of this distinction helps avoid subtle bugs and ensures that object copying behaves as intended in Python programs.